Tokenization. What? Tokenization is the process of splitting a text sequence into smaller units that are called tokens. Tokens are the smallest meaningful elements or symbols in a text. The word tokens is derived from the concept of linguistic tokens, which are units of language that convey meaning. Let me show you an example using this phrase. The quick brown fox jumps over the lazy dog, which is an English language pangram. That is a sentence that contains all the letters of the alphabet. And to show you tokenization, I'm going to use the OpenAI tokenizer, which you can find in platform.openai.com/tokenizer. This is a tokenizer, which is where you learn about the language model tokenization. In here, you put a piece of text and it shows you how it will be tokenized. Please note that this is by model. And if you're wondering, it's not a one-to-one relationship. As you can read at the bottom, the rule of thumb is that one token generally corresponds to approximately 4 characters of text, but this does not always apply. When I type this sentence, you can see that each token is each word. That's mainly because these are short words. These are 9 tokens with 43 characters. Now, when I click on Show Example, this has a much more complex piece of text. As you can see, many words map to one token, but some don't. There are several words that are divided into multiple tokens. Whenever you want to learn how GPT is going to tokenize your prompt, please use the tokenizer. Also, if you want to tokenize programmatically, you can use TickToken, which you can find here in GitHub. TickToken is a tokenizer for use with the OpenAI models. Here's how you use it in Python. Given that tokenization is an essential concept in natural language processing, it's very important for you to know how it works, especially because you're charged based on the number of tokens. Additionally, let me tell you a few more reasons of why tokenization is important. First, text processing. Given that computers perform operations efficiently on smaller units like tokens than on entire paragraphs or documents, when you tokenize, it simplifies the text processing task. Also, tokenization allows for statistical analysis of text, enabling tasks such as frequency analysis, sentiment analysis, and topic modeling. Also, tokenization is a crucial step in language modeling, where models learn the statistical properties of tokens and their relationships within a given language, which is what I mentioned before. The GPT model is like a very smart autocomplete, and tokening helps this. Also, tokenization simplifies the process of feeding text data into the model. It makes it easier for the model to process, calculate, and generate the text. Additionally, tokenization involves mapping words to unique numerical IDs based on the model's vocabulary. This mapping allows the model to work with numerical data, making it suitable for machine learning algorithms. Remember this example? If I touch token IDs, it's going to give me the numerical IDs for these tokens. And finally, tokenization is typically integrated into the pre-processing and post-processing pipelines of natural language processing tasks, which helps you prepare your text data before inputting into the model and decodes the model's output back into a human-readable text. In summary, tokenization is a fundamental step when you're working with a GPT model because it simplifies the text processing, manages the model's input size limitation, and enables the model to understand and generate text effectively. There are different tokenization strategies that can be used depending on the specific task and requirements of your application.